All right, so number 9. During a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. So let's say they start right here, and Jackie goes this direction, and Peter goes this direction, but they start with an angle of 15 between them. So I'm going to say that that's 15 degrees. Jackie skates for 5 meters in one direction, Peter skates for 7 meters in the other direction. And if I close my triangle, my goal is to figure out how far apart are the skaters. So at this point in time, how far apart are they? So if I look at my oblique triangle that I drew, I'm either going to apply the law of sines or cosines. And so it looks like I have, or I know I have, side angle side. And so you want to ask yourself if that's enough for the law of sines, or if I have to use the law of cosines. I do not have any angles directly across from any sides, so the law of sines is out, and we have to use the law of cosines, which states this. The angle that you have, you can find the side directly across. So we have that the side I'm looking for are the other two sides added up, minus 2 times the sides you have, cosine of my angle, 15. So what I would do is plug this directly into your calculator. So plug in 5 squared plus 7 squared minus this product here. And if you do that, you would get, I'm just checking myself as well right now, you would get x squared equals 6.385 and so on. Again, I would keep this in your calculator. I would take the square root of both sides, and if you do, you would get a final answer of 2.52 meters. So this one definitely did not take as long as the last 3, because we happened to have the angle directly across from the side, and it was nice, and I would call it like a plug and chug type problem. Number 10, the last one I'm doing. A vertical flagpole is attached to the top of a building. Okay, so let me draw a triangle that I'm going to assume is right, because again, I hope that my building is perpendicular to the ground, otherwise we might have some construction issues later on. So a vertical flagpole is attached to the top of a building. So we have this flagpole on the top. A man stands 400 feet from the base of the building. The base means bottom. So he is 400 feet from the base of the building. From his viewpoint, which is right here, the angle of elevation to the bottom of the flagpole is 60 degrees. So his eyesight from where he is to the bottom of the flagpole is already drawn, and so the angle of elevation would be right here, 60 degrees. His angle of elevation view from where he is to the top of the flag looks like this. And this angle of elevation, so from the ground up, which is this entire angle, is 62.5 degrees. Which means if this whole thing is 62.5 and this is 60, this little angle here would just be a very little 2.5 degrees. So there are some things I know so far. Our goal is to find the height of the flagpole. So in the end, I would like to figure out what this h is. And so the h is part of this oblique triangle that I drew. So I have my right triangle, which will come in handy, but my eventual goal is to use the law of sines or cosines with the oblique triangle. So let's see what I can do. The only side length I know is in this right triangle. And ooh, I found something that's some good review. This triangle right here is a 30, 60, 90 triangle. So we know that this side is 400. You could use trig to figure out either this side or this side, but why not put in a little review here? So a 30, 60, 90 triangle, we know that this side across from the smallest angle is 400. And you might recall that this was x root 3, and 2x. So if this is 400, this is double, or 800. So without even using right triangle trig, I know that this length right here is 800. So let me redraw this oblique triangle so you can see it more clearly. So it looks like this. And then here's the height we're trying to find, and then we're coming down. So here, oh my goodness. So this is the height I'm trying to find. I know that this is 800. I know that this angle is 2.5. And my goal, again, is to find that height right there. So if I wanted to use something like the law of sines, I could do sine of 2.5 over h but then I would need to know this angle to do sine of something over 800. So let's see if we can find this angle. Well, I know that this angle's 30, and this angle right here is a supplement to it. So this angle here has to be 150 degrees. Try that again, it's a little bit not neat enough there. So that would be 150. And so if this is 2.5 and that's 150, the remaining angle up here should be 27.5 degrees, which means here it's 27.5 degrees. And now I can use the law of sines. Sine of 27.5 degrees over 800 equals the sine of 2.5 degrees over the height. So if I cross multiply and solve, I would have 800 times the sine of 2.5 degrees divided by the sine of 27.5 degrees. And if you plug that into your calculator directly, you would get that the height is 75.57 feet. Flagpole is 75.57 feet above the building.